All right, let's take a look at section 3.4, proofs with perpendicular lines. To get us started right here, let's take a look at our first term, which is the distance from a point to a line. Now, if I have a line and I have a point right here, I could draw millions of lines from this point to the line and figure out what is the distance. Well, officially for us in geometry, well, we're going to say the distance from that red point to the line is going to be the length of the perpendicular segment from the point to the line. So right here, the only correct answer that I want is going to be this length of this segment that is perpendicular from the point to the initial line. Okay, that is the distance, not just any random line that we draw from the point to the line. Our next term right here is perpendicular bisector, and that could be a ray, line, segment that will cut another segment in half and create a right angle. Our perpendicular lines are two lines that are form 90-degree angles, and if it bisects, it will split one of the angles or one of the segments in half. All right. So now let's take a look right here at theorem 3.10. In theorem 3.10 right here, the linear pair perpendicular theorem, it's saying that if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So if angle 1 and angle 2 is congruent right there, and I see two lines that intersect, the only possibility for that to be able to, for those two angles 1 and 2 to be congruent is if they're both perpendicular. That is the only way. Or they're both 90 degrees. Otherwise, we can't get ourselves a straight line, right? So these two angles 1 and 2, if they are congruent, they can only be one thing, and they're 90 degrees. And that tells us that line G and H are perpendicular to one another. And don't forget, this right here, this upside down T, is your perpendicular symbol. Next up, we have perpendicular transversal theorem. So, in a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So if I have two lines that are parallel, H and K in the diagram, and I know for a fact that J is perpendicular to H, it must also be perpendicular to line K, because we have two parallel lines. So think about this, two parallel lines cut by a transversal, these angles right here that I'm looking at, they're corresponding angles, and they're going to have to be congruent. So if it's congruent to one and it's perpendicular to one, it will be perpendicular to the other if I have a transversal cutting through parallel lines. In theorem 3.12, lines perpendicular to the transversal theorem. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So if I know that M and N are both perpendicular to line P, and line P is the transversal, then what that tells me is that line M is going to be parallel to line N. All right, and that is the lines perpendicular to transversal theorem. Make sure you know the names of these theorems here. All right, let's move on and take a look at our extra practice. All right, so it says we want to find the distance, and take a look at number 1, from point A to line BC. So point A right here, line BC is down there. Now remember, you can see we have three different lines that go from this point to line BC. But the only one that I care about when I want to find the distance is this one, because this segment is perpendicular to the line. So what I need to find right here is the distance of segment AD. They give us points, so all you need to do right here is use the distance formula. So let's find the distance of A to D, and that's equal to, and remember we got our distance formula, and we got ourselves -1, and we're going to go ahead and put minus -3 quantity squared plus -2 minus 0 quantity squared. So remember, our equation for distance formula, x2 minus x sub 1 quantity squared plus y2 minus y sub 1 quantity squared, and then you solve it out. So let's simplify this. I got -1 minus a -3. That'll get us a -4, or sorry, that'll get us 4, or 2, and 2 squared is 4. -2 minus 0 is -2. You square that and you get 4 as well. And so we get ourselves right here, AD is equal to the square root of 8. Always simplify as much as you can, and the correct answer to this would be 2 rad 2. And that is what I would want on my test. Alright, so 2 square root of 2 is the distance from point A to line BC. Alright, so make sure that whenever you do this, you always choose the correct points. You have the point itself, and then you have to figure out the perpendicular to the line. Sometimes in order to do that, you're going to have to actually find the slope of the lines to find these which two segments or lines are perpendicular. Okay, remember, like I said, you might actually have to find the slope first by either counting or using the slope formula to determine which line is going to be perpendicular and what you're supposed to actually choose. Okay. And number 5, determine which lines, if any, must be parallel. We got to make sure that we have enough information to do that right here. So if I look right here, I'm looking at P and Q, and all I know is that P and S are perpendicular, but I don't know that Q is perpendicular to S. Okay, so right here we could go ahead and say none. The reason being, all right, there's not enough info. Okay, remember line Q you can go ahead and say line Q must be perpendicular to line S. And there is no information on that. Let's go to number 6 next. All right, so we take a look. I see 2 perpendicular symbols right here. And so how about I use this as my transversal? I've got right here line Q and line P going through that transversal. And so look, these 2 angles right here, they happen to be perpendicular or 90 degrees. And since they are both in the corresponding position, I can go ahead and say right here that P is parallel to Q. Okay, and I guess the official reason right here is lines perpendicular to a transversal theorem. All right, and that's why those 2 can be perpendicular or parallel to each other. We take a look at number 7 next. We've got a lot of 90-degree angles here. I've got 90 degree, 90 degree. I can go ahead and say this is the transversal, and we have ourselves right here parallel lines, or the two lines that are going through that transversal. So there's the first part. So let's go ahead and say right here, since they both happen to be perpendicular or 90 degrees, I can go ahead and say that J is parallel to K. We have lines perpendicular to the transversal. Well, let's take a look right here. I also see that I've got a 90-degree angle right here. And I got a 90-degree angle right here. I could say that this is the transversal, and M and N are right there. These two lines happen to be parallel as well, because look, I've got 90-degree angles. And so we can also say right here, because of this, that M is also parallel to N, and its lines perpendicular to a transversal. Because remember, if this is 90 degrees, then that means this is 90. And then these two angles are corresponding. Not only are they perpendicular, or 90 degrees, but they are also corresponding. All right, and then we have next up, number 8. Let's see what we could say here. I've got right here, angles 1 and angles 2 are congruent. Okay, so if these two angles are congruent and S is a straight line, that means that these two angles have to be perpendicular. So one thing that I will already automatically say is that we have a linear pair, perpendicular theorem. Okay, and so let's take a look. I've got 90 degrees here, 90 degrees here. If I say that this is the transversal line S, and then I've got two 90-degree, both M and N are perpendicular to S, then I've got lines perpendicular to a transversal. So I can go ahead and say right here that M is parallel to N. Got lines perpendicular to the transversal. Let's take a look right here. I've got this perpendicular, and line N is the transversal. So what that'll allow us to go ahead and say is that S is also parallel to T, and that is lines perpendicular to the transversal as well. And there you have it. We use these proofs to prove that we have ourselves perpendicular lines. And that right there is section 3.4.